Hey everyone, today we're going to be starting out a new chapter, Chapter 2, and we'll be working on Lesson 1, where we'll be solving equations with rational coefficients. Our objective is to solve equations with rational coefficients, and please make sure to gather what you need. You'll probably need a notebook and a pencil today. So to start out today, we need to talk about the inverse property of multiplication. The product of a number and its multiplicative inverse is 1. So kind of a fancy term, multiplicative inverse, but basically a multiplicative inverse is just a fraction flipped. So if we have 7/8, if we flip it to 8 over 7, that's the multiplicative inverse. And the reason we do this is because when we flip a fraction and multiply, 7/8 is multiplied 7 times 8 and 8 times 7. Each of these would equal 56, which obviously equals 1. Same with this negative example. If we start out with the fraction negative 3 over 2, the multiplicative inverse is negative 2 over 3. We multiply straight across. 3 times 2 is 6. 2 times 3 is 6. That's going to be equal to 1. It's actually negative 6 over negative 6. The numerical factor of a term that contains a variable is called the coefficient of the variable. So a quick review. When we've got a value like 3x, the number 3 is the coefficient, and the term x is a variable. So in the equation 3/4 c equals 18, the coefficient of c is a rational number. So a rational number, being a fraction, is the coefficient. To solve an equation when the coefficient is a fraction, you just simply multiply each side by the multiplicative inverse of the fraction. So an important point to remember is whatever we multiply one side by, we have to do the exact same on the other side of the equal sign. So let's take a look at that example. We've got 3/4 c equals 18. We're being asked to solve and then check our solution. So in order to get c alone, we need to take 3/4 and multiply it by its multiplicative inverse, which is 4 over 3. Basically, in this case, they cancel each other out and equal 1. So we're just left with c in our equation on the left-hand side of the equal sign. Now we've got 4/3 times 18. And remember, any whole number we can put over 1. So we've got a fraction, and we can factor out our problem. So if we factor out 3 from 18, we get 6. And if we factor out 3 from 3, we get 1. Makes it much easier to multiply. So we end up with 4 times 6 equals 24 over 1 times 1. And our final answer is just simply 24. Now to check our answer, we're going to put our final solution, 24, in for c and see if we get the same value on both sides, if it's an equal equation. So if we take 3/4 times 24, remember we put that whole number over 1, so we've got another fraction to work with, makes things a lot easier. So let's factor 4 out of 24 to get 6, and we'll factor 4 out of 4 to get 1. And then we multiply straight across. We get 3 times 6 is 18. 1 times 1 is 1. So 18 over 1 equals 18. And that solution does work because we get 18 on each side of the equal sign, so it's a balanced equation. So next, I'd like you to try these problems on your own. Work them through, and then come back and check your answers. So let's start out with A. Got 1/5 x equals 12. So I'm going to rewrite the problem just to give myself some more room. Remember, the strategy is I'm going to multiply 1/5 x by its multiplicative inverse. I'm just going to put that in parentheses to stand for multiplication. I have to do the same thing to the other side of the equal sign. And I'm going to put 12 over 1 as well, just so I remember that I'm multiplying it as a fraction. So the left-hand side, the multiplicative inverse cancels out 1/5. So we're just left with x on the left-hand side. And then when I multiply straight across, I get 12 times 5 is 60. 1 times 1 is 1. So I get x equals 60 over 1, or just x equals 60. Next, I've got b, which is negative 2 over 9d equals 4. So again, and rewrite just to give myself some more room. I'm going to multiply negative 2/9 by its multiplicative inverse, so negative 9 over 2. I have to do the same thing to both sides. The left-hand side cancels out, so I'm left with d is equal to, I can factor out 2 from the 2 and the 4. So if I factor out 2 from 2, I get 1. Factor out 2 from 4, I get 2. It just makes my multiplication that much easier. Now I've got 2 times negative 9 is negative 18. 1 times 1 is 1. So d is equal to negative 18. Next, for c, we've got 15 equals 5 over 3n. So same type of problem, just written in a little different order. So again, I always like to rewrite the problem. 15 equals 5/3 n. So what I want to do is back up, and I want to write my multiplicative inverse first. So I'm going to write 3/5, put it in parentheses, because I'm going to multiply that by 5/3. Then I can write 5/3 n. And then I'm going to put 3/5 on the other side as well, because I have to multiply that by 15, or 15 over 1. Cancels out on the right-hand side, so I've got n on the right-hand side. And again, I can factor out between the 5 and the 15. Factor 5 out of 5, I get 1. Factor 5 out of 15, I get 3. When I multiply straight across, I get 3 times 3 is 9. 1 times 1 is 1. So my final answer is 9 equals n, or I like to write it the other way around. I can just flip it, n equals 9. And for our final problem here, problem D, I've got negative 24 is equal to negative 6 over 7p. Again, rewrite. And I'm going to write my multiplicative inverse first in parentheses. So I got negative 7 over 6 times negative 6 over 7p. And I have to put my multiplicative inverse on the left-hand side as well. So negative 7 over 6. I'm going to put 24 over 1, so I have a fraction there. Right side cancels out, that's the easy part. Now I'm going to factor out 6 from 6 and 24. So 6 divided by 6 is 1. 24 divided by 6 is 4. And now I can multiply. And remember, this is a negative 24, so negative 7 times negative 4 is positive 28. And 1 times 1 is 1. So I get 28 equals p, or obviously p equals 28 when I flip it around. So that's it for today. I hope the examples went well for you, and we'll be going through more examples tomorrow.